One, on to you.
A very warm welcome to Lean for Sustainability session. My name is Juha Tammi. I'm General Manager for Lean Association Finland and moderator for this session. We will have actually two presentations, the one coming from Alessandro Orsi and the other one coming from Scania, Karin Boström and Maria Boding Johansson, who are presenting their case. And first of all, we'll take the presentation from Alessandro Orsi, optimization of green construction projects through the implementation of the lean approach. Alessandro comes from a Green Building Factory. He is a master in science in building engineering. He holds also a master degree in construction management. That is from Michigan State University. The first one was from University in Trento in Italy. And he is also a PhD from the Polytechnic University of Valencia in Spain. And there he focused on the optimization of green building projects through the implementation of the lean approach. He's also accredited professional from to lead and pre-M. And during the last 13 years, Mr. Orsi has been working as engineer and project manager within the field of green building, construction and sustainability across Europe, USA, Brazil and Australia. And he's director and co-founder of Green Building Factory, a company that provides integrated services for sustainability-related developments and collaborates with different universities in Europe and the US. Alessandro, please go ahead. The stage is yours.
Thank you, Juha. Let me share my screen then. You can see me. You can see the presentation, I guess, right?
Yes.
Perfect. Well, thanks a lot to everybody for being here. Especially, I would like to thank the LIPS, the Lean in Public Sector organization, and the Lead of Finland for having me here and for letting me joining you today. So today we are going to take a look at the optimization of the green construction projects through the lean approach, and then we'll start. A brief introduction to explain where do we start from, and then we'll pass on to the practical implementation of the lean. So the idea of implementing lean within the sustainability and within the green construction project field come from a research study that we did in collaboration with the Polytechnic University of Valencia and the Michigan State University. It focused on the implementation of lean within the green construction field. And the idea was quite simple because it came from one of the key concepts of lean construction itself. Koskela in 1992 said that judging from the manufacturing experience, construction could realize dramatic improvements simply by identifying non-value adding activities. So the idea was to take out the waste from the processes. An idea that following a traditional approach of the green construction can be explained as follows. So you have a designer, you typically have a designer, a general contractor, or an owner that develops a project or a design and then gets some consultants to tweak the project or to adapt the project even alongside to the green needs. That's why we're called consultants. The thing is, the idea is that if we know there is some waste in this bit, how much more waste do we generate down the line? So the idea of implementing lean within this sector was to focus on that bit of the traditional process. And so we had this case study research. We got 4 real case study projects, 1 school complex, nursing home, 2 office buildings, all in Southern Europe, 2 of them LEED certified, and 2 of them BREEAM certified. And by the end of the study, we developed a methodology, we validated, and by the end of the study, we focused on the results. So on how much waste did we detect within these green building processes. So these are the results. It's a very short table. But basically, the results in terms of wastes, they were specified in terms of extra costs, so added costs to the original budget in order to pursue the green construction features, delays or extra time implemented for the same purpose, and loss of green construction features. You may want to take a look at the variance because you have some quite big numbers. We are referring only to the design process for these case studies, and there will be many considerations to make, but this is not the point. For example, the difference between implementing a design-build rather than a design-build process. The first one turned out to be much better than the second one. The huge benefits of implementing an IPD approach, the positive relationship between project management and green building features and vice versa, and other results. We gathered all these results within what we call Green Building Factory GBF method, but the key idea here was to use Lean only to detect the wastes within the process. Since this is not really the key of the point of this presentation, I leave you here some links if you want to take a look at the research study more deeply. We did a webinar for the LIPS Association, Lean in Public Sector, and it's free. You just go into their website, you register, and you get it's a 1-hour webinar where we explain all the outcomes. And for the GBF method, you have a link to our website. But again, this is not real the point of the presentation. This was just the starting point to start implementing Lean within the green construction field. So now we are going to see how could be the practical implementation. Because after that we said, hey, how could we design better processes? How can we not just detect the waste, but avoid it from the beginning? And so we split this presentation in 2. 1, practical implementation for services, and then there will come the practical implementations for procurements. In relationship with services, we tried to develop a sort of IPD for sustainable construction, and it worked like more or less like this. Going back to what we just said, we have the standard approach where you have the designer, the traditional know-how, the project, and then the green building tweaks or the consultants. And this happens generally, or at least for the vast majority of projects that we see, for different types of services, like energy modeling, life cycle analysis, commissioning authority, thermal comfort modeling, and others. The problem is that throughout the process, the project development process that I summarized using the RIBA stages, so from the initial idea to the concept design, technical design, to construction and use, these services are called in very punctual times, and they are generally provided by different suppliers. So you may have one supplier doing the energy modeling, thermal comfort, the other commissioning authority, the other lighting, etc. And all these consultants are tied to the owner or to the general contractor with separated contracts. So that makes the process extremely fragmented. And the real problem is that whenever you have a problem, is always everybody else's fault. And so we try to solve that, creating what we call operation management team. We don't approach the project from the timeline point of view, but from the field point of view. Here is just an example: architectural design, mechanical, procurement, project management, structural, whatever. We know that the architectural design for a building, for example, can take place at the beginning, but then if there are major change orders during the construction, it may require an option later. Now, the idea is to approach the project from these fields' point of view and having an expert in charge of each field, an expert of that field, knowing things about the type of green construction that should be promoted. The expert follows the task to the end of the field, not of the architectural, for example, the structural design or the construction. It's not necessarily time related. And the most important thing is that all experts come down to one company which has one single contract with one owner. So all the problems are dealt with within the company itself. However, if we want to look at it more realistically, if we look at it considering the knowledge, the green building or the green construction knowledge, we often see that technicians nowadays in the market do not have a lot of time the required knowledge. So you may have somebody that has more or less, which an average, but they do not meet the required. So the idea of having somebody, an expert on top of each field, is also to integrate the lack of knowledge for each field and bringing everybody at the same level. And plus, all the experts would be connected, so if there's a problem on the other side, the communications are much quicker. So that's how we try to create an IPD for a sustainable project. The idea is then to have all services that we saw before provided by one single supplier, and therefore limiting, standardizing also the processes and limiting the problems. Ideally, what we do for middle range projects, we would like to be involved in the design as well, because this brings, it's like a design build process for sustainability, and it brings a whole bunch of advantages to the benefits of cost, time, and sustainability issues. Just an example, if the guy who designs the HVAC is the same guy that develops the energy modeling, he has all the knowledge and all the data as he's drawing, as he's designing the project. He doesn't have to go back and look for all the details afterward. We implement also another approach. We try to build quality within the process, and I come back to the energy modeling standard approach. So the energy modeling, for the ones that are not familiar with, is a model of the building that tells you the building performance from the energy point of view. So for example, if you have thermal bridges, if the HVAC is properly designed, how does the pipeline work, etc. So the standard approach, as we see it now on the market, is that during the process, you call in one consultant, typically by the end of the technical design, that develops the energy modeling, and that's it. The problem is that in order to develop the energy modeling, you need all the data of all the informations of the building, because you have to know the U values of the windows, or the efficiency of the heat pumps, etc. But as we see a lot of times, is that once the energy modeling is developed, nobody or very few people at least care, because we get the data, the information of the building. It takes us 1 to 2 months, depends on the building, to do it. And once the energy modeling is done, which should be done to optimize the energy performance, they say, oh no, the project has already been approved, has already been bid out, and we cannot modify it. We'll do a change order. But that's not the purpose, we say. So how do we try to build in quality? This is just an example. This happens also with CO2 calculation, commissioning authority, and everything, okay? What is the purpose? Do I really need this energy modeling? And so if we do need, and if we want to use it, we try to approach it from an integrated point of view. So we start earlier on, during the early design stages, with a kickoff meeting, sharing the knowledge with the owner and with the guys, the clients, basically. Doing a first step to design, try to help them design the passive requirements, the passive, function of the energy performance, and then the active energy performances. And then developing a second energy modeling, and then coming to the final step. So this service is turned into different steps, which increase tremendously the quality. It costs a bit more if you do it in the standard way, but the results are much better. Another way that we try to implement lean in order to get better processes, we try to do this last planner for sustainability related tasks. I guess you are familiar with the last planner method, but basically going back to what we just said about the fields and the experts, depending on the green feature that your bridge, your building, your road wants to to fulfill, you will have different inputs from different fields. So the architect, the structural engineer, the mechanical, whatever. Okay. So each sustainability feature may have different inputs from different fields. So we said, we need to know, everybody needs to know who does what, when, and what are the other one's needs. And this has to be constantly, possibly, if possible, visualized in order to know who's doing what. And so we linked, we thought about linking these things and these activities and these inputs, and label them with a mark with the activity idea, so who does what, when, linking the predecessor and successors, which are not strictly time related. The dependency, again, is not strictly time related, and then label them also through visual Kanban. Not only like the blue and red that you're seeing here, but to notify some what we call critical paths that are similar to the critical path of scheduling within project management. I will explain it in a second. And lastly, a list of constraints that will have to be technicians will have to focus them and solve them on a weekly and monthly basis. I just said about the visual Kanban and the constraints, and these thing we found that this thing works pretty well with the reference standards, such as LEED and BREEAM. Why? Because these reference standards work through credits, and the credits, a lot of credits are linked with each other. So you are now seeing an example, and you are seeing the BREEAM, the first part of the BREEAM table for these credits. So you have the certification levels: pass, good, very good, excellent, outstanding, and then you have the issues or the credits. So the building feature that you have that you may want to have if you want to certify. So if you want an excellent level of certification, you do need the MAN04 credit. But if you want a very good, you don't need to. And these are just 3, but for each protocol, you have 20 to 30 different credits. And so we found within this last planner system, a good solution to keep these relationship visualized and the constraints that are being solved throughout the process. We now step into the other section. So the practical implementation focused on procurement. And we are now I'll try to explain you our KPI Kanban system. So I'll go back once again to the traditional system, but before you have to think about the sustainable market like this. You have the sustainable construction, and you have different branches. We are talking green buildings, green sustainable infrastructures, green finance, and then on the other side you have different tasks and different tools that we can use in order to achieve this. So like analysis, CO2 footprint, energy use. Now, according to the traditional process, it's the last time I'll talk about that, I promise. We said that you have a designer and you have a traditional know-how. So the designer or the GC develops the design and the project as they would normally do, and then they go to green consultants to tweak it. The problem here lays on this traditional know-how, because whether in the example of we just said about the energy modeling, the designer generally has a certain knowledge of the issue. So the energy performance of a building, an architect, even he is not a professional ASHRAE accredited technician, he knows that a double glazed window insulates less than a triple glazed window. He knows more or less the centimeters of insulation that a house may need in where he works. It depends on if the building is in Mexico or in Finland, of course. But the problem is that for these things, that traditional know-how was there. But for these new tools that now sustainability imposes us, they are not. Because for CO2, for example, you ask an architect or an engineer how many tons of CO2 footprint is the bridge, and we saw that they do not have a clue. And they do not have a clue because you need to calculate it. So we need to find an alternative to the yes and no process, because generally these consultants, tweakers, they get the inputs from the general contractor, and the general contractor said, hey, you have to tell me if that's yes or no material. Okay. So this is just an example for the CO2, and this happens for the other KPIs as well. But for example, for the CO2, we use BIM. So building information modeling. And through BIM, you have different approaches. So if you select a wall, for example, like such, you can get the CO2 information through an EPD, Environmental Product Declaration. So the producer of the brick gets you the bricks with the certification, And he said, look, this brick is half a kilo, so half a kilo CO2. So you just get the certificate, you multiply it by the area, the volume, and you get your CO2. Another way is to get it from database, specific databases. EcoInvent is one of them, where you just basically link the object in the database to the object in your BIM model. And or the last way to do it is to calculate from scratch using the life cycle analysis approach. So you have to calculate where the bricks come from, how big the trucks are, etc. So these three methods imply an increasing level of effort. So the easiest is, of course, the first one. You get the certificate and say, hey, look, this is how much CO2 I get. The most difficult is the last one, where you have to calculate everything. So with BIM, we managed to design our model, BIM model, adding some properties to materials. So if you look at the bottom right, you see these are the wall, and the bottom right you see CO2 EPD, CO2 database, and CO2 SIMA Pro. So within the BIM model, we select we tick the box, and depending on which box you tick, the walls are here green, EPD, yellow if you go to database, or SIMA Pro if you have to calculate them. This means that every time that somebody goes into the model, the BIM model, and finds a new way, or links a new way to calculate, or link easier way, or links the object with the database, he would color that object yellow or red if he has to calculate everything. So it's just a visual translation of what is going on. The problem is that not everybody uses BIM. And so we have to find a way to transfer these informations down the line. And so we said, we look at the takeoff documentation, and they were all black and white. And so for one pilot project, we said, sorry, can we paint them? And I said, yes, no problem. So these information are transmitted via PDF, so everybody can read them. And we developed a Kanban system in order to define what is the CO2 footprint, or at least give an idea of what the CO2 footprint is. So the code, the color of the code defines the impact on that element on the project cost. If it's below the 0.2%, it's green, so you don't really have to bother about calculating it. If it's between the 0.2 and the 3%, you may want to calculate it because it starts to get big. If it's above 2%, it's red. Okay. On the other side, you have the colors on the project title, so these ones. And so you have green if the data come from EPD, yellow if they come from database, and red if they come to lifecycle analysis. And so the idea, the input given to all the construction guys working, was very simple. It was a Kanban chart saying, look, if you find green, green, or yellow, green, or red, green, it's okay, because it doesn't impact much the project. If you find these other combinations, you may have to improve the calculations, because you will have to link the database at least. And be careful that if you find these other combination with red, yellow, red, etc., you have to get on and calculate them, because otherwise you get to the end of the project and you don't know how much CO2 you have. This, of course, is quite detailed method that we implemented for quite large projects, so $90 million euro bridge. And you have really to calibrate the method, because you have to know why you're doing this thing. So do you have a need to meet national regulation? Do you want to get into the CO2 European stock market, green finance? This is another approach for corporate analysis, CO2 calculation, with a software that does it all automatically, that we trade with our partner. And so there are different inputs. The thing is, and these are the conclusions, that sustainability is giving us new challenges to meet. So whether they are emission reduction, climate change, circular economy, green finance, whatever. The technical side brings us tools to fulfill these challenges. The problem is, and that's where lean comes in, how. So how we are going to use these tools to meet these new challenges, I guess it's the point that we are making. And you can use IPD method, you have to standardize the projects, reduce the waste, etc., to meet the real fulfillment, the real goal, which is to make sustainable projects that are also affordable. That's it. Thank you.
Thank you, Alessandro. Very nice presentation. Thank you. Let's go to questions then. One question here. Most often, problem is getting good, reliable data in life cycle calculations. What do you think about this? Or isn't it a problem for green building more? Sorry, isn't it a problem for green building maybe?
So the beginning of the question, I lost it.
Yeah, most often a problem is getting good, reliable data in life cycle calculations.
Yes, again, it really depends, because if you want, for example, if you want to trade your CO2, your tons of CO2 in the European exchange market, you want to have very detailed calculations. So you have to go some very strict parameters that are imposed by European market. However, if you, for example, want to, within the green finance, the banks are now trying to attract clients by proposing a tool to calculate their CO2 footprint corporate for free. So where do they get the data from? We don't know until you do it. So it really depends. It is a problem, but it can be solved by getting exact clauses or very detailed requirements within what you're asking for. Because if you're asking for a CO2 footprint calculation, it doesn't mean anything. It's like asking for a sustainable project. It doesn't mean, if you don't tell me what sustainable is, there are so many ways to calculate the CO2 footprint. You have to really detail the every single thing if you want to do it clear.
Another another question related to carbon dioxide is, some materials like concrete is making huge amount of carbon dioxide. Do you see a shift in using concrete or some other materials which are like heavy on CO2?
We are seeing, we operate in different markets. So, for example, I'm originally from the Alps, and in the Alps, there are a lot of wooden structures. But, for example, I worked in Brazil, where they have huge forests and excellent wood, but they would not use wood to for the construction because they are afraid of parasites. So even if there are products against the parasites and the insects, their cultures tell them not to use them. So from the sustainability point of view, I would hope for a shift. But from the cultural point of view, I'm not seeing much.
All right. What about you said about the different reasons for aiming for greener buildings? Are you seeing kind of a trend there that some countries are more doing it by legal way, pushing the constructions and builders, than other countries or markets maybe doing more like developers and constructions want to do?
I've been working within this field for almost 15 years now, and I'm sad to say that whenever somebody asks for sustainability, is quite never for sustainability itself. If you're looking at the building field, a lot of residential, for example, you can either get the developer that wants the green building to be sold at a higher price. You want the politician to get a green bridge to promote his image, to have a feedback on their image. We have regulations coming up. The good thing that I'm seeing is that so far, at international level at least, LEED, BREEAM, Passive House, EDGE protocols were the biggest ones. And now the European community, for example, is putting up new requirements, quite strict, by the way. So it will be, sustainability is not an option, but it will be mandatory by law soon. And so until now, we saw just the private interest. Now we are seeing the legal and requirements coming in. And I guess with these two joined together, then also the public culture will follow.
All right, good to know. Thank you. One more from the chat box. Great concrete examples, Alessandro. I feel that getting green thinking aspects integrated to one's processes and daily work is important, not having them as separate things. I like you were showing in your examples. How do you think we get more towards this?
The knowledge is a big thing. So that's why I cited it. Once we are called in, generally for a project or a consultant, we try to bring everybody to the same level. Now, how can we get more? I guess by educating the new generations, and by growing up, because as I said, until now it's a pull system. It's not a lean pull system, but it's pulled by the higher stages. No? So politicians, developers. We get some ideas from smaller investors and stuff, but as they see, sustainability costs more, then I'm not willing to do it. But it does not have to cost more. It's just because the process is under which the projects are done follow the standard approach. If as I said before, if the designer, the mechanical engineer is the same that does the energy simulation, with one click, and not one click, but instead of spending 1 month, he spends 2 days to do it. So there are dramatics, but it has to come from under, and we don't see that need of sustainability for construction at the, I'd say, social level now.
All right. Thank you, Alessandro. There's still possibility to ask Alessandro in the end of the session, but now we move on to the second Second presentation. Thank you, Alessandro.
Thank you to everybody.